Good morning, ladies and gentlemen. My name is Mayanne Grace. I'm the Head of Projects at the Edinburgh Chamber of Commerce. I'm delighted to welcome you to our webinar on circular economy in the construction sector. We've got a panel of speakers today, but just to let you know a bit of housekeeping. First of all, the session will be recorded and will be uploaded and promoted after the session. Also, if you can please put yourself on mute, but you will get a chance to ask questions later on at the Q&A session. I'm delighted to introduce our first speaker, who is Nick Ribbons, Sector Manager for Construction at Zero Waste Scotland. Over to you, Nick.
Cool, thank you. I'll just unmute myself. That's great. So, as Mayanne said, my name is Nick Ribbons and I work for Zero Waste Scotland. And what I'm going to do with this presentation is just really set out what the circular economy is in terms of how we understand it and how that really relates to construction and how that applies in this instance. Oh, there we go. There's a bit of a lag here, so apologies. So this first slide is really about understanding, why we're focusing on the construction sector in the first place as an organisation. And part of our aim in Zero Waste Scotland is to be the circular economy and resource efficiency experts for Scotland. And so we focus on a number of key areas, and construction is one that we identified quite early on as being really important for the reasons set out in this slide. At a sort of UK level, around 50% of the resources consumed go into the construction sector in some way. And around 50% of the embodied and operational carbon as well are derived from that sector. So if we're going to meet a lot of the ambitious targets that are in place, it's something we need to focus on, and we need to focus on now. At a Scottish level, it's about 50% of the waste we produce comes from construction. What that tells us is that we're really inefficient in terms of the construction sector. A lot of that is sort of inert waste, but there's also a lot of things like offcuts, and I have a slide coming soon, which is something we recently looked at, which is what is in the skip for a particular project. We also know that it's a hugely important sector in terms of within the economy. It's about 10% of GVA, and I think around 7% GDP, and about 1 in 10 people in the workforce works in the construction sector or the supply chain. So this is a really interesting analysis that we did. It was called sort of the True Cost of Waste project, and we'd been using data which had been from a study which was over 10 years old, and it was from a very small sample. This isn't much of a bigger sample, but it's refreshed data. What we want to understand is the true cost of waste. So often people just equate how much it costs to get rid of your waste with, say, skip hire. You can see here that the skip hire is around just over £200, but actually you break that down, and there's a lot of value just being literally thrown away, some of which will be recovered, but often it's contaminated, or it's maybe recycled in the sense that you might say it's downcycled. It's used for energy from waste and that sort of thing. And there's a couple of interesting pie charts here. I don't really have time to go into them, but I'm sure these will be shared, and you can see all the images and the speakers' notes. But what's interesting is that a lot of the condition of the waste is in a very good condition, particularly on a house building site. A lot of what goes into the skip is newly procured material that's become offcuts or has become contaminated through on-site storage or damaged through on-site storage and handling. Basically, what we are kind of trying to drive home here is that this is entirely preventable. We also looked at different building project types, but we envisage this data, we've developed a methodology for collecting it, and we envisage it getting more robust as we gather more. So a note of caution in drawing conclusions about this, but I think you can do. So taking a step back and looking at this at a global scale, at why we're tackling CO2 and where we think sort of the circular economy can help. This slide was updated, I think, in June, but from previous presentations, we basically update this slide year on year because this spike keeps on climbing. And we know that this is having disastrous consequences. It's causing severity and frequency, or frequency and severity of extreme weather events, and the impact these have on our sort of society and environment is really, really intricately linked to the buildings, the built environment that we use. And if we, you know, the sort of environment that we're going to live in the next coming decades is going to be wildly different, and it's already changing, and we need to sort of try and anticipate that, and then retrofit our current building stock, which is largely what we'll be using, but we also need to be understand, you know, how this is going to affect the building stock. You know, we're still delivering houses which don't have cooling facilities, and that's something we maybe need to anticipate for the future. You know, we're still building on floodplains, but that's a different matter altogether. Another interesting graph here, we're looking at, this is a sort of a nominal price index for just commodities in general. But it's again intricately tied to the construction sector. You know, going back to that first slide, a lot of the resources that we use go into the construction sector, and you know, I've drawn a best fit line here, which shows it's very obviously climbing, but actually, if you take that to the past 20 years, the line becomes a lot steeper. And this unpredictability and uncertainty impacts the supply chain. And actually, if we think about, you know, something like 60 or 70% of the materials that we use in the UK are imported from Europe and the rest of the world. If we can begin to harness the circular economy, we can actually shorten those supply chain links, and we can create a more robust supply chain within the UK, and actually insulate ourselves against fluctuations in global markets, and protect SMEs, which we know are the sort of lifeblood of the construction industry. So when we talk about our current economy, this is the way it works, and with each link in this chain, there is CO2 emissions. At Zero Waste Scotland, we're really keen on trying to shift this focus from just in-use emissions and operational emissions of buildings to the embodied emissions. And it is a bit of a minefield. It's a very difficult landscape to navigate. There's a lot of information there, but we're now at the point in time that we need to start facing up to this. So from the resource extraction to the manufacturing to retail to use to the waste, and actually there's a step beyond that in terms of your next lives of waste. We need to begin to try and understand you know, how these emissions sort of add up, and what goes into the end product. One way of combating this is this idea of the circular economy, where we repair and reuse, refurbish, and, you know, conserve best we can, and we build things with if we frame things in this context, then we begin to design and build things, not just the buildings themselves, but the materials and fabrics that compose them. We build them with these things in mind. And I apologies if you've heard me present this slide before, but I think a key takeaway is that with each sort of increase in these concentric rings represents a loss in value. So, you know, key here is obviously sort of, I'm an environmental professional, but this is about economy, really. This is about value retention. And every time we have to bump an item to the next level to reuse it, to recycle it, we're losing value. Obviously, incineration and landfill is the least preferable option, but we should maybe shift our thinking and think, well, is recycling, you know, unless we can upcycle something and increase the value, that maybe the least favorable option, and we shouldn't even really be considering landfill and incineration as an option. I know that's a bit of a big leap, but it's maybe something that we should begin to think. And as well, it's about shortening those supply chain links. It all ties into the good old waste hierarchy introduced in the EU Waste Framework Directive, where it's basically best use to worst use, or most preferable to least preferable. And I think there's a huge scope here for not just reduction in implementation of design techniques by engineers and architects and design teams, but also the reuse is probably something that we don't build buildings to be able to extract materials in a high value state. We design them in such ways that they're bonded together and they have to be completely destroyed, or in some cases with buildings that are older, that have been built with high quality materials, we can sort of extend their lives. This is slide I've just thrown in here, as we see it, the key drivers for change within the construction sector. So we need it really to be demand driven. We need to form these bonds with clients. So in particular, I see clients that own and occupy, design and demolish their own estates. So the likes of local authorities, sort of health facilities, universities, and these sorts of organizations, they have a huge amount of control in the way they sort of procure things. So the way they ask for buildings and what they ask for, that is changing, we need to see that a bit more rapidly. But also skills, because if the clients are asking for new things to happen and things to be delivered in more circular ways, then they need to be confident the supply chain can deliver that. So there's a bit of a chicken and egg thing going on. Also skills in terms of procurement. It's not just this labor shortage that we hear about in construction all the time. With bricklayers and painters and decorators and this sort of thing. We need skills across the board to, we need everybody to be sort of circular economy literate. But we also need help from the government. There's a big policy gap here in terms of the building regs have focused for a long time on in-use energy consumption. And this thinking needs to shift, and there is space. The way the way the regs have been written allows for consideration of embodied carbon at a later date, but I think it's because it's such a complex problem, it's something that hasn't been dealt with. And again, all this needs to be framed by research. We need to be backing up what we're proposing with sort of sound research, which is another thing that we're keen on doing at Zero Waste Scotland. So I think I have around 5 minutes, Mayan, or am I at time now?
You've got a couple of minutes, if that's
a couple of minutes. I'm not following this slide. There is a case study for each of these, but hopefully you'll take some time to look through this. But in general, these are sort of 10 circular economy principles in construction that we, Zero Waste Scotland, are sort of advocating. Now, these many bleed into each other, and also there is crossover. It's not an exhaustive list. I fully understand that, but these are approaches that we think are certainly a good start. Material recoverability, for example, designing in layers is something was proposed, I think, maybe even before the 90s. I think Stuart Brand, an architect, proposed that. Understanding, that the different layers of the building have different lifespans, and if you appreciate that, then you can design in such a way that you can maintain and repair your building with minimum fabric disruption, minimum disruption to occupants. Collaboration, that's a key point set out within BIM. Smart construction, there's a lot of digital tools within the construction industry that we really aren't maximizing utilization of. Also carbon sequestration, low carbon, including reused materials with recycled content, and the plastics tax is going to impact that, but also a lot of natural materials, wooden and wood products. And there's also a lot of projects going on right now with the Scottish Government. So unfortunately, I don't have time to go through each of these, but there are some really good examples here, as you can see, and it'd be great if you could have a look at them. And my email's on the slideshow, and approach me and quiz me on as much of it as you like, and I will try my best to get back to you. So there we go.
Thanks for that, Nick. Our next speaker is Aythan Lewes, Director at GLM. Over to you, Aythan.
So yeah, thank you, Mine and Nick, and thank you to Edinburgh Chamber for hosting this webinar. Let's see if I can get this moving. Okay, so that should be on page 2, Mine. Yeah.
Yeah, I can see your image there.
Great. It's raining here in Queensferry, so I'm just checking the internet's holding up. So yes, today I'm going to speak about our experiences working in a way that supports the principles of a circular economy. I've been asked to give some examples, which I'll do at the end. But first, I'll talk about who we are and why we should be talking about this subject. Then I'll talk about building surveyors in general and what we can offer by way of support for the circular agenda. Following that, I'll present some ideas for data capture and sharing and some examples. Obviously, knowing what is currently out there in the Anthropocene is clearly an important starting point. So that's a large part of what we do, as is working collaboratively. I'll then talk about ecosystems, so estates that we can work within, focusing on groups of buildings controlled by one owner. And then I'll talk about some of the challenges we faced during internal sort of churn fit out work. And then I'll finish with some stories of those materials we have successfully worked with in a circular fashion. So just a quick introduction to us. So GLM, so who are we? We're a firm of building surveyors and architects. We work primarily with existing buildings. Our background as building surveyors means that we're sort of intrinsically sustainable. And I'll explain why I think that on the next slide. We've taken as our own the well-used Carl Elefanti line about the greenest building, because that is always our starting point. Our sustainability credentials were sort of more implied than explicit for many years. And it's only in recent times that we have become more communicative about our ideology and our approach. The graphic on the left here shows some of the key themes underpinning our thinking on the facets of sustainability. Of course, it's the top one that we're talking about today. As for me, my name is Aythan Lewes, as Mine said. I'm a chartered building surveyor. I'm a director of GLM, and I've spent my career working between Scotland and Ireland. GLM work on capital projects and maintenance activities. I've decided to focus today on the maintenance side of things, and that'll keep me away from the sorts of things that I think that Lily will be presenting on later. We do work with Narrows quite a bit and deliver a lot of great capital projects, but it's our work with the buildings in use I'll focus on today. So building surveying. Building surveying is a much misunderstood profession, and that includes by building surveyors themselves. We are the perennial jack of all trades and master of none, but it appears that we're actually quite uniquely suited to supporting a circular economy. Much of what we already do meets the needs of circular practice. So we extend the life of buildings, we maintain and adapt them so that they remain useful. Now that retains the embodied carbon and avoids carbon cost of new fabric and services. Research shows clearly that the sub and superstructure to be the most carbon intensive, so just avoiding full demolition saves about half of the embodied carbon in a building. During our survey work, we catalogue building elements and put them into schedules. I mean, that's putting it as simply as I possibly can. And then we share these schedules with other people in lots of different ways. We work to make things as maintainable as possible, naturally preferring things to be a loose fit because it makes our lives easier when we have to maintain or alter them. We are champions of high quality work because it lasts longer. We're also champions of lessons learned, since it's typically us who have to pick up the pieces of bad buildings. We tend to live in REBA stage 7. So whilst the architects and engineers occupy the sexy and well-funded stages of 1 to 6, we tend to be slumming it, supporting the poor benighted facilities managers living with latent defects and design decisions from decades past and dealing with it all on a shoestring budget. So reuse and recycle are often necessities, not just fashionable buzzwords in the world in which we tend to work. And we've been doing this for decades without really even thinking about it. It was good that Nick there introduced the 10 construction circular economy principles, because that is a good tool that I've used to identify how building surveying sort of connects in with the circular economy and how our work at GLM connects in. So I was just going to quickly run through these and talk about how we would interpret these in our world and in our work. So first off, collaboration, and obviously this comes down to communication. So how do we pass on our findings about buildings to other people? So we've surveyed the building. How do we pass that on to others? Other interested parties, in so many stakeholders, buildings changing hands, different occupants coming in, different tenants coming in, and how do we shape that data so that other people can use it? Whole life value. As surveyors, we see the original creation of the building. Obviously I work next to colleague architects, so there's the original creation. But we tend to also then be involved in the maintenance of that, the adaptation of that. So we see it from cradle to grave, as well as all the boring bits in between. So we have a vested interest in the initial build, providing well-functioning buildings in all ways for the decades of its life. Health and well-being, not necessarily a core focus of our work, although I do think that sometimes we overlook the good work we do for people's health by upgrading buildings, making them work better, making them drier and warmer. Long life, loose fit. So as I mentioned earlier, we know that buildings have to be maintained and often see them being pushed way beyond their design life. I've seen patches fixed with screws, knowing that the patch will expire and have to be unscrewed and a new patch fixed again. So this is this sort of loose fit concept that something needs to be destroyed to take it away or to maintain it or replace it. So typically though, I find that this comes from necessity, not necessarily thinking about the planet. Low carbon. So as far as embodied carbon goes, I would say that building surveyors are masters at this, although not intentionally. Extending the life of buildings retains the embodied carbon in them and reduces the need for new fabrics, or keeps down the carbon emitted in production. But this is often in conflict with the drive to reduce operational carbon. The ability to make these decisions, so the sort of toss up between embodied carbon and operational carbon. So, if you want to cover a building with lots of high performance insulation, there's typically a lot of carbon emitted in the production of that insulation. So you bring down your operational carbon, so the carbon from burning fuel to heat the building, but you've then incurred a lot of carbon in the production of that insulation. How do you make that decision? I think that we all need better tools to be able to find our way through that one. Smart construction. The use of IT, as Nick said, is growing in the construction sector, not really leveraged as much as we'd all like it to be. However, building surveyors, it's now a staple of a lot of what building surveyors do. So you find a lot of us going around with tablet-based apps for data collection. So if we're scheduling buildings, scheduling maintenance work, some will still do it pen and paper, but a lot of people now these days will be using, so you're talking about Kai Cloud, Go Report, these sorts of applications. The coming Internet of Things actually is worth mentioning too, in terms of tracking buildings, putting sensors onto them, that sort of thing, being able to share data through the coming Internet of Things with 5G, I think is something which will also add to our ability to track building materials and really sort of hopefully contribute towards circular thinking. Material recoverability. As building surveyors, we can be as blind to this as anyone at specification stage. But once in use, we can tell you if something like a cavity barrier is accessible or not, because we're typically having to maintain it. By the way, if your cavity barrier, if it comes to the end of its life at 15 years, but your monolithic facade lasts for 50, you might want to reconsider your design. We have seen that. Design out waste. Designing around common modules not only makes sense at initial build, but when we come to replace things as well. Circular products and services. In our facilities support, we've seen FM firms providing and selling heat rather than boiler maintenance. And so if you understand the difference between those two approaches, we've seen that for many years now. But how long until roofing companies provide a dry, warm house and not just tiles? This is an area that definitely needs work, and I'd encourage people to look into it more. And material management. Again, our work, our core work, cataloging buildings already takes us 90% of the way there on this. So it's not much of a leap to put this data on a common platform for all to see and use. So that's the theoretical bit out of the way. So data capture and sharing, this is really at the core of what we do. So we maintain both of these buildings. They're both very different, but to do so, we use similar processes and tools. So our work would always start with a survey to understand the building. So in this case, we would be using a planned preventative maintenance schedule, a PPM, which schedules the elements, describes their condition, their repair needs, and gives a cash flow to help the client budget. From a cyclical perspective, this work means we're looking at a lot of the Anthropocene every day. We are literally walking around staring at what happens to be in and on buildings. To harvest materials already on buildings, we must first know what's there, and our bread and butter is doing that. So I've listed here the points at which a building surveyor might be called on to look at a building. At GLM now, we're working to add commentary to survey reports, primarily when working through the maintenance phase of a building's life, as to which materials are present that can then be recovered and used elsewhere. This circular focus, looking ahead at key milestones such as renovation or demolition, is only of use if we can share this data more widely, either around a group of buildings in common ownership, and again, Nick referenced estates there, which is something I'm going to talk about, or to a sector-wide market, and not enough of those exist at the moment. So that's another key thing that we'd like to see come online to help this sort of circular approach. So data capture and sharing. The hope for the future is that technology will allow us to really take the data that we're currently gathering and share it more widely. So already we're working with large property owners to digitize the records of their buildings to assist with maintenance. And we did that with Glen Eagles here. Again, Nick mentioned BIM, using BIM hierarchies, COBie data. We can use this to make this data accessible to a variety of users. Hosting data on a cloud server to assist with this access, and linking it to a computer-aided facilities management platform to gain efficiencies in maintenance. All of these things becoming more and more common practice. We recently worked with the Chris Stewart Group to catalogue their portfolio, giving them numbers of windows, areas of stonework, areas of cladding systems, of roofing systems. Now that exercise was to assist with planning maintenance. It's not a big estate. You know, they were using a computer-aided facilities management platform, which is very low cost, works for small estates, you know, taking what was practice for only very large estates and really bringing it down to those smaller ones. But the trick is to make that data set that we're giving to one client about their estate accessible to all, so that, I mean, the sort of nirvana future state that we'd like to get to is that an architect can select a system currently on a building from a virtual salvage yard. So we're already surveying buildings with drones. To use this to quickly capture areas and materials from the exteriors of buildings would be a large, if fairly straightforward task. Of course, your structural frames, internal finishes and services, that's a different matter, far bigger job, but the principle remains the same. And this is a sort of the place we'd like to see things pushed to. Estate-wide collaboration, I mean, Nick mentioned this, as I said. So to share data across a whole sector is difficult, and probably one of the big steps to take to make a circular economy a reality in construction. But however, this can be developed in microcosm by looking at estates of buildings, either commercial estates, so the Phoenix group of buildings that we currently help maintain, or rural estates, or housing associations, public sector, educational campuses, or similar. Working with these small ecosystems, we have found that instigating new initiatives and protocols, implementing basically internal markets, is much simpler. Seeing how groups of commercial office buildings can share system components across their buildings, or seeing where simple differences between systems can get in the way, shows how this can be rolled out more broadly across the wider sector. Like everything in the sustainability agenda, holistic thinking is key. So I want to give an example here that showed the real challenges of acting in line with circular aspirations, even when the actual aim of the project should support it. Commercial interiors are some of the worst offenders for skipping large quantities of reasonably young materials, huge amounts of waste. Several years ago, the RICS developed SCAR rating, which is a system designed to promote more sustainable practices in this sector. It quickly sank from view. It was meant to be a BREEAM or LEED competitor, because if you've ever used BREEAM or LEED, you'll see that most of the points that you get relates to shell and core rather than fit out. So SCAR rating was meant to sort of close that gap, but it doesn't seem to have done it, unfortunately. It's actually quite a good system. I used it on this project. This project came from the client looking to make a workplace far more sustainable, and the team set off with this in mind. Many of our efforts to design out waste, to reuse materials, and design for recovery and the like fell down at implementation. The initial survey didn't fully identify what was already in place and its suitability for reuse. But where we did recover them, materials were found to be unfashionable, so did not meet the new aesthetic. Consultants and contractors failed to sort of trust the performance of recovered materials. This is particularly the case with structural engineers, which I'm sure Lily might talk about later on. The wear rate of many materials, perhaps coming through a VE exercise when first specified 10, 20 years ago, means that they're typically worn out by decade number 3. Some systems we'd hoped to reuse had been epoxied in place. Systems whose parts should have been recoverable and reusable were either no longer in stock or they were incompatible, often due to minute differences with the modern versions of them, so raised access floors, partition systems, ceiling systems. So much like the ever-changing Apple iPhone charger, obsolescence is planned in, and if the wider sector does not enforce common standards, we're going to keep seeing this being the case. Finally, the frenetic pace of fit-out projects leaves very little time for reacting to conditions on site. To work with recovered materials, you either need an excellent record of what is there already, and who of us actually trusts O&M manuals, or you need time in the build phase to understand what is there, adjust the design accordingly, and have flex in the cost management to allow for reconditioning and a variety of types of reuse, because you never quite know what condition you might recover some materials in. Of course, knowing the materials prior to start on site is preferable, but then there must be time invested into the survey stage and often cost allocated early on for opening up. This is sometimes too much to ask of already pressurized clients and consulting teams. In contrast, some of the common success stories that we found are in traditional materials and systems. And this is where the conservationist in me comes out. I started my professional life as a wannabe architectural historian, and it's in this world where we found the easiest wins. The common currency of reclaimed Scotch slates, shown here in their natural state of falling off a tenement roof, is probably the best example of circular practice. For decades, there has been no new stock and the supplies dwindle. Driven by legislation, in this case, listed buildings being forced to have specific materials used on them, this precious stock has a lively market and increasing price. Materials are tracked, traded, cared for, and valued. What we see is the combination of natural scarcity and legislative control, creating circular thinking and practice. Our work with many of Scotland's finest buildings, as well as many tenements, show how these two forces make this simplest of building components one of the best examples of circularity in practice. So the question is, how do we bring these forces to bear more widely? The photo below it is a stone which went into a new window opening in a byre on Mull. The stone was quarried by locals within a mile or two of the byre and installed into the floor. During conversion, the floor was to be insulated, so the stone flags were repurposed into these rybats. The flags could be taken up so easily because of the weak mortar in which they were sat. No hard cement binder, no adhesives, no nail fixings. The cost of moving materials to Mull drove the decision to repurpose what was on site rather than buying new. Again, we see the need for alignment with commercial aims to create the conditions for circular practice. Plastics are where the true circular service that is mentioned in the 10 core principles can come into its own. So for instance, if Seeker could put in place a service like a bottle return system, so when your single ply membrane comes to the end of its life, Seeker will take it back and take responsibility for its recycling. We might just have an answer. Sadly, I think it will take legislation to create this sort of environment. Concrete is a huge challenge. It's massively carbon intensive and very hard to separate once cast. Even precast units are grouted in place, making it hard to separate them at demolition. What if we did the same with concrete as has happened with Scotch slates and stopped new concrete manufacture? Do we think we'd be more careful with the existing stock of concrete? Steel holds great promise, but needs braver, more considered structural engineers, as well as connection details designed with recovery in mind. Historic fabric and buildings lend themselves to circular practice because the societies which created them were energy poor and so valued the reusability of hard-earned building elements. Slate, stones, mortar, and timber were all very hard to come by before the age of easily transportable hydrocarbon energy. To get back to such a world, we must respect the materials again, enough to avoid wasting them. We can choose to do so, or we can wait until we're forced to by climate change disrupting our economy and putting us back 100 years. So it's up to us. And on that cheery note, I've come to the end of my slides. So thank you very much, Mine.
Well, that's great. Thanks, Aythan. That was really interesting, especially the life of a surveyor. Who knew? So thanks for that. Our next speaker is Lily Rose Erskine, Senior Designer from David Narro Associates. Over to you, Lily. Yeah, we can hear you. Yeah, we can hear you, Lily. Yeah, we can see your presentation. So you're ready?
Okay, perfect. So rather than focus too much on the theoretical, as my colleagues have just talked you all through, I think, I have decided to talk to you more about a project that I've worked on for the last 3 years, and it's in the very north of Scotland. We've got several sites across there, and I have the weighty task of managing all of them in my role as senior engineer at David Narro. So we cover structural engineering and civil engineering. So it's my presentation is going to focus on those elements more than the other kind of built environment professions. So just to let you know where we're talking about, this is where my sites are now. My office is in Edinburgh, and so it's quite far north, further north than I think I've ever been before. We are 247 miles around the North Coast 500. And to zoom in, these are our sites. So we have a whole suite of projects up there. It's all one client. And we're quite lucky in that the client is particularly keen on following a sustainable path, but also very driven to maximize on the quality. So we've got a relatively unique situation where we have the time and the kind of backing to develop things which otherwise we might not be able to do. So this is from the top of our scaffold. The site is absolutely spectacular, and that's representative of all of those sites that I just showed you. So there is a very visual reminder of why we need to be responsible and respectful with what we're building and what we're designing. And we have a whole collaborative team, of course, of excellent architects, ecologists, all working towards this common goal. So on site, we have a whole load of wildlife. All of these chaps are present, but quite critically, we have a burn that runs through the sites. And the burn is one of the last breeding grounds, natural breeding grounds of wild trout and wild salmon. They are particularly susceptible to just dying off forever, it turns out. So if the pH of the water changes at all, that's the end of it. They don't come back, they're done for. So from the beginning, we had this very serious situation where even by following the most stringent of SEPA advice, we couldn't guarantee that we could protect the environment. So we decided to eliminate all in situ poured concrete from the build. So that was kind of the starting point, but actually it lent itself really well to developing an almost completely circular way of building, which possibly otherwise we wouldn't have come to, because it's not the easy option, of course, and it's a learning process, and you have to have clients who are willing to let you do that development. So just to go back to circular economy very briefly, what we're talking about is first of all looking around. We're in the middle of nowhere, as you can see, so a lot of the costs to do with carbon and to do with money are in the transportation. So looking at what we can source locally and what we've got on site, what we can reuse. My background is largely conservation, and so using those historic buildings is critical to the approach. And of course, the quality of the materials and the quality of the build lends itself to reuse, as we've just heard. What we then looked at is how we can get things to site in the most efficient way. Now, that lends itself to, again, financial and carbon impacts. If we can just transport the things which we need, rather than transporting waste, we can work in a way which will be naturally better for the environment. So we adopted a off-site manufacture process. So we have big warehouses. It helps with the weather as much as anything, being in the north. But if we build things in a modular fashion, we can build them in a way which can be dismantled. We can try them out on site. We can try them out in the warehouse. We can take them down and we can reuse them. And inherently that means that the building can have a life after its current designed one. So I'm going to talk you through a couple of these projects and just tell you about the things that we've done. So in terms of reuse of material, this is one of the smaller projects that we've got. This is a very fancy render that Grover Rains Architects kindly sent over, because we don't have that sort of technology in structural engineering. So the two timber buildings I'll talk about later, but what I'd like to focus on now is the little cottage that you can just see a glimpse of there. Now, that cottage exists, and it's been there for probably 100 years at least. There's actually a little ruin in the garden that's much older. It's an old crock house. So there's been people on this site for several hundred years. The problem is, as anyone who has ever rented a cottage in the north of Scotland will know, they do tend to be either rather chilly or lined in some sort of plastic that means that they're rather damp. So we needed to get this to a point where you could stay in it and have neither of those issues. So what we decided to do was quite interesting. We've taken the building down course by course. So we're being respectful to the vernacular, and there are conservation principles imbibed in that. So keeping the language of the landscape. We've palletized the entire building course by course, and what we've done is cut the stones vertically in half. So what we're doing is forming a cavity wall construction using the materials that we have on site, building it back up as an insulated property, using the same quoins in the corner, the same lintels, but that building is now suitable for modern habitation and meets a much greater R value. I mean, there are tricks that we've had to have. It's not quite as simple as I make out. I mean, we've had to put in a precast concrete interior because a big thick stone wall is strong en masse, but as two thinner skins doesn't work in the same way. So there's a bit of structural support in there. And I'll talk you through how we've dealt with precast later, because we've got a whole system for that. So just up the road from there, we have this little set of buildings, which are all the ancillary buildings for the estate in general. So we've got the staff accommodation, the meeting rooms, the formal kitchen, all those kind of ancillary buildings that rural estates have. Now, these ones we looked at, now the burn that I was talking about earlier is just off the bottom of this image, so it is really close. And we had to do a lot of regrading of the landscape to make this work. So we ended up developing a system of precast beams. Now, precast, as was previously mentioned, generally has always been grouted together, and that's where you get your robustness. So you have a series of parts, generally cast with reinforcement sticking out the end, and then you glue it all together. Now, the same with in situ concrete, doesn't work in a circular sense because you have to destroy it in order to reuse it. So what we started looking at instead was timber connections. Now, timber is great, you can undo it, you can put it back together. So we looked at things like IKEA furniture and Japanese joinery, where we can build in geometric principles that mean when you put the items together, they naturally lock in and become inherently robust. So we have to achieve a big old, I mean, the size of these buildings is significant and we've got big chimneys in them and things, but we needed a strong base, and we managed to do it in a way which you could pick up, reuse in 50 years' time when the building perhaps has lived out its design life. I mean, we'd like to think that these buildings would last 100 years. We've designed to an elevated life anyway for sustainability reasons, but these elements are inherently reusable, much like a massive set of Meccano. You can see there that we also did infill just to add a little robustness, because when you cast something in a monolithic sense, it is solid. If you put in joints, you do kind of get a little bit of movement, so you have to design that in. So things that we added in, like packing in ground in between, so that compacted soil is all from a small plant that we set up on site. So when we reconfigured the landscape, we regraded into a type 6N mix and compacted it in between the precast elements just to enhance that robustness. So this is the methodology in practice, really. We set the whole thing up in the warehouse. So we were able to do the snagging early on. We could tweak the design, we could get the client on board. So we had a benchmark to work to. And you can see there that we're only going to be transporting the exact units that we use on site. So immediately, working in an incredibly remote location, we reduce the carbon impact of transportation. And we have this added benefit that we're not using in situ concrete, so we're protecting the environment at the same time. So those are the exact same frames on the left as on the right, and scaled up to almost a small hamlet. We also did all the timber infills as panelized modular units, and these things go up in 3 days. So you reduce all the costs of craneage because you're there, you pop it up, bam, 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 and you've got a building in under a week. It's an exceptionally efficient process. So we've talked about existing buildings and how we use them on a small scale. And again, the modular units, that's relatively small scale. But what I wanted to talk about now is how you scale that up into a big project. So this building here is the kind of jewel in the crown of the estate. So it's a timber Victorian hunting lodge, and the bit in the centre is all existing. What we're doing is extending it to make it a new modern building. So we've got a basement on the right-hand side, and on the left is a timber extension. So basements almost always are in situ poured concrete, which we ruled out. And so we had to look at methodologies of building basements in a way that used precast. Now, that's another render there, but that's the building as we started with is on the left-hand side. So we started looking again at modularization, at ways that we could build in component parts that you can put together using dowel joints and clever cast-in situations. This means that we eliminate wet joints and we can dismantle, we can reconfigure. Famously with precast, you have to have a huge front end because you can't reconfigure the elements once they're on site, they're there, you've got a shape. This method means that we can take them, we can change them. If there are late project client changes, for instance, or site discoveries, we've got units that we can use that are all relatively standard as far as we can. There are a few specials, but largely standardized units. We can change their shape, we can rebuild them in different ways. So the entire thing can be dismantled and reused in a completely different location if you wanted it to. So just to bring it all together, this is the site that we're working with. You can see that we have sort of surgically removed parts of the existing building, carefully put things that we can reuse to one side. What's actually really interesting about this bit is we, at one point, picked up the entire building on a set of temporary work. So we built a huge bridge that held the building in the air so that we could build underneath it. So at no point did we have to take down the existing structure. We kept as much as we could. So with clever propping, we were able to do that. And that is inherently more sustainable than taking it down and rebuilding it, for instance. And you can see here that even things like the blocks that we used as retaining walls, we've been using them to support temporary works. So you can design in ways that things can have more than one life and reuse across the site. And so again, we're bringing fewer things to site. Our transportation carbon emissions are going down. The actual value that we're getting out of our elements is going up every time we use them for a different thing. And so by creating multi-purpose modular units, we've been able to get as far as we can towards a circular approach in a very high-end, big-scale project. And that is me, and that is the team.
Thank you, Lily. That was really interesting and brings it all to life when you actually see a project like that, rather than just the points, but the project of circularity and embedding it, and also seeing all the environment and animals around it. I think really brings it to home how important it is to embed circularity in construction. So our final speaker for this morning is Poul Wendhansen, Environment Manager at Balfour Beatty. So I'm just going to hand you over to Paul.
So some great presentations there. Thanks, everybody. And that final example, I think, is a really good case study of where, you know, that early engagement, obviously, because of its location and what you were doing there, Lily, you're all driven to collaborate. And I think that's going to be the main point from my presentation. I'm an environmental scientist. I work with Balfour Beatty. I've been in the industry for over 20 years. And I was just thinking about that, listening to the presentations. And I suppose my circular discussion started back in 2004 when I helped write a Syria guide called Design for Deconstruction. And so, you know, that's a long time ago now, too long. And we're still talking about this. I suppose that's one, you know, the thing is, this is complicated. Hopefully, I'm going to highlight some examples of things that we always do and we already do. Some of the presenters have already covered things that we already touch and already deliver. But for me, then on scale, how can we continue to develop that and actually do it on a larger scale and more consistently, I suppose, is the bit that I'm always thinking about. So yeah, I'm going to go through what Balfour Beatty are focused on, hopefully, you know, with the aim that that'll help us get more consistent circular solutions. Then look at a couple of case studies which highlight things that we can already do and we're already doing. And then, you know, just look at that and think, right, how can we continue to scale up these solutions and, you know, do it in a more consistent manner. So in terms of Balfour Beatty, I can summarise what we're focused on. It's really modern methods of construction, off-site construction as an example, digitisation, use of BIM, embodied carbon assessment and the adoption of biodiversity net gain. I think they've been touched on by all of the previous presenters. I'm just going to unpack them a little bit from our point of view and why we're focused on them. But what you have up here is just a summary slide as we see of UK infrastructure sector trends. All of these are papers that we've responded to on our corporate web page. So, you know, if you want to read anything else, then you can just go to our group web page and you will find them there. And it really sets out, you know, what we see as this, but as the key challenges and key opportunities. And as I said, for me, the main one is that early engagement. How do we get designers, engineers, customers, contractors, and supply chain to collaborate further up the design process, preferably REBA stage 2. We've heard a lot about that, but you know, that's where we need to be, because it's decisions that are made there that lock in, you know, what the actual outcome is, whether that's deconstruction, demolition, new build. You know, it's these founding principles that need to be in there. And unfortunately, at the moment, the contractual process doesn't really enable that. So it feels like it's a new innovation every time, when actually it really isn't and shouldn't be. So just to reinforce what Nick said, that, you know, linear construction, left to right, it's the age-old, you know, economic industrial process. And it's really about inputs. You've got a lot of waste in the middle, and then you know, you end up with the output. Nick summarised for Scotland. I've taken some figures for the UK. These haven't changed that much in over the 16 years that I've been looking at this. You know, 60% of UK material use, 30% of the value, and as Nick said, 50% of Scotland's waste, you know, lack of accessible data. This is something that you were touching on, Aythan, within your presentation around O&M manuals, and the fact that there's just this disjointedness in the process. It's not connected up, and it's not, you know, the information isn't readily available. And obviously, digitization offers us a really good opportunity to address that. So, just taking the Europeans' view of what circular economy is, and this is from the European Environment Agency. So you have design for disassembly, material passports, selective demolition, extension of construction life, and high-grade products with highly recycled content. You know, for me, you know, they're all of the key areas that we need to be focused on, and they're all of the ones that have challenges. We do little bits in all of these at the moment. We just don't do it on a big, you know, coordinated, consistent manner. So some of the opportunities as I see them, really around circular construction and digitization. Then you have the project management model on the left there. Again, that's been there for a fair few years now. However, it just feels like that there are, you know, different walls, contractual walls through that process, and different groups across the different groups in that process. Some of them are understandable, but they lead to challenges because they don't allow that overall collaboration in general, and that's mainly driven, like I say, through the contractual process. But you know, things that need to be in there at the start to really help us think through this is that, you know, commissioning from customers of actually having a digital twin, you know, getting the BIM model well developed before specification and procurement is locked in, and then, you know, thinking about saying, right, there's the built environment's already there if it's a, you know, an existing building, and that a lot of carbon energy has already gone into that. So like, let's change our thinking of that. It's actually a material bank. You know, how can we, as we've heard from some of the other presenters, how can we identify materials for reuse, recycling, design for deconstruction, you know, and really think that at the end we're going to end up with something that is a bank which has value, inherent value in it, which we need to retain. And you know, that then moves into this whole building management system, and having a BIM model which then tells you what products you use, what the specifications were, have they been leased, is the servitization in there, and that really would help, you know, obviously the building assets use in terms of its efficiency. But also, if you can build in the data collection over time of how the asset changes, it would help when you get to the end of life and start thinking about, or change of life, I should say, rather than end of life. You know, how do you actually then, how are you able to rethink that building instead of just saying, hey, let's demolish it. I think that's where Lily's example came in really well. You know, it's obviously hindered there through its location, but you couldn't immediately say, hey, we're going to demolish this and build something new. If we have them constraints, which I think we are starting to see, you know, through material supply and embodied carbon, then that's, you know, going to change our thinking when we're looking at these more urban and city centre areas. So just an example of this, you know, material flows, you've got something we did many years ago on the left, which is just, you know, looking at a customer's portfolio and saying, right, how do we rethink the refurbishment of your building and, you know, really apply designing for deconstruction, so that assembly, flexibility, reassembly, repurposing, minimize the use of scarce materials, and then maximize reuse of materials infrastructure components, the use of modern methods of construction, off-site, modular, increase recycled content, and then make sure that, you know, materials that are sourced, they are done in a sustainable way, and that we have carbon reduction in there. I think if you have them kind of, you know, philosophies in how you're thinking about, you know, delivering or new construction or refurbishment, then they're going to change how you go about actually sourcing materials, and you might think about more localized regional solutions rather than international procurement of materials, as an example. So one key point I've been talking about is this earlier customer engagement, and you know, this graph is very simple. However, it really does, you know, for me, hit home that if you're starting to move into the definition and design of a building, then you're already locked into, you know, what it is that you're going to deliver. And you know, it moves back to the property management diagram that I showed earlier. How can you get everybody engaged at this brief and concept level? Because that's where these, you know, you really need to think through, hold on a minute, can we servitize something? Can we reclaim these elements of a building? And I suppose just thinking back on my experience, when I've seen that happen best is when, you know, it's been dictated by the building, whether it's, you know, a listed building, or whether it's a location, or whether there's this ultimate goal to actually do something different, you know, increase the recycled content of materials, as an example. You know, if there's a real drive there from a customer, then it'll happen. But they can't do that alone. We all need to be working together. And I just think that over the past 10 years, the industry has struggled through the fact that each section of the process through the rebate gates has been separated through basically the commercial contract process, and that just stifles a lot of innovation. So, you know, I'm going to look at a couple of examples where that didn't happen and we did get some good collaboration. However, you know, I am going to caveat that these two examples, you know, there's nothing new in these. These are things that we can already do. And we can do them really well if we, you know, focus on it. So this was from 2016, and in London, St James's Market is where that material flow diagram came from. And it was going, right, how can we just think about this process in a more upfront manner? And by doing that, then as you can see, we achieved 98% of demolition materials were recycled and reused within local London boroughs. That's something that we're already good at, but there were some really, you know, good wins in there, which was like, you know, the reuse of carpet tiles, slates, switch gears, and salvage reinstallation of 10 tons of ornamental lead work. So there were some big things in there that were driven already by, you know, the building and the refurbishment angle of it, and that was beyond what is usually achieved. And then 98% of construction materials recycled and reused. So, you know, that's reclaiming, but again, it's the next point, you know, it is that lower value, unfortunately, but, you know, again, it's not a bad thing. It's not just getting chucked in a landfill is the point, and these things are things that we're already good at. Waste per metre queued was reduced by off-site prefabrication, reusable packaging solutions. So again, really doing that upfront thinking about how it was going to be delivered, and having the time to get that in place and getting the supply chain solution in place. Recycled content of materials, 25% for carpeting, plasterboard installation, and 60% for steel and concrete products. And then product life extension, it was a listed facade. So, you know, that was obviously matched with a new build and upgraded so that it was treated as a new build, and you could have all of the product life extension that you'd get from a new facade in there. So, you know, these ones here around the recycled content, this is something that is achievable, but is it specified regularly and, you know, and commonly? I don't think it is. It's because this had that upfront focus and drive from the customer, the Crown Estate, to actually have that built in there. And, you know, another example of this, of having that upfront process, was we worked in Glasgow on Kelvinside Academy, and we were lucky enough that a guy called Doug Morwood, who does a lot of work in circular economy, is part of the governance board of Kelvinside, and basically caught the project just in time, so that we could say, hold on a minute, we've got an initial design, but like, is there, you know, something more that we could do to facilitate circular economy and whole life thinking in the project? And I suppose the headline is we were able to do some of the things that we wanted. Unfortunately, because it had already gone down a certain route on the design, there was some elements that we couldn't resolve around servitization of key elements in the building, but we were able to, you know, go, right, let's just take a step back, have some facilitated workshops, have a think about this, and how can we actually, you know, rethink this process. And it's a small project, but it became a really powerful one, because it's a really good example of you know, applying circular economy and whole life design thought to it. We came up with a very simple circular economy tracker. It's something that we're building into our design process. You know, if a customer is ready and willing that that's the way they want us to collaborate with the designers, architects, engineers, then it's there. If not, we can use it to actually, you know, challenge the thought process and where they are. You know, is a customer really going to achieve their goals and expectations in how it's tracking? And some of the results, you know, are there. Structure cladding, that was designed for deconstruction, so that ongoing maintenance point of view, it could be, you know, it has that inherent value. It's a material bank. Design refined, that led to half the number of distribution boards required throughout the project. So, you know, that you would call that value engineering in old parlance, whereas, you know, for me, it's actually just going, hold on a minute, let's stop and think, you know, the design that's off the shelf, has that gone far enough in thinking this through? And I've seen many an example through my career where something that's just designed without that thought actually goes through and it gets constructed, because you don't have that review through the different stages and through the contract process. Internal spaces, for me, this is the really big win, rethinking the whole space and future-proofing it. So it's flexible, it's adaptive. It is a school, but they can change it from workshops to larger areas, and it can really, you know, flex depending on where the school are heading with their training and programs. Then specification of the smart building management system is something that's always sort of lost or not really fully done. And then therefore you end up with a building management system that somebody sort of dusts the manual off when they open up the project, say, right, how does this thing work? It's fundamental to make the building efficient in use, that you're actually thinking about that up front, and, you know, what it is that is going to feed into it, but also how that BMS is going to be used. After, you know, many a year doing facilities management, I've seen that all too often. And, you know, you end up with this 5-year period where you're building up the knowledge, and it's like, well, why are we spending 5 years to do it when we could be doing it and thinking about it up front? And I think that's one of the real opportunities we have with BIM and digitization now, which is to get smarter and quicker about these things. You know, off-site construction, prefabrication of ground beams and pile caps. We are fortunate enough to have a prefabricated concrete factory. So these are the kind of solutions that we can actually bring to that when we're involved in the design, and that also goes for our M&E, Balfour Beatty, Kilpatrick. And then off-site construction, steel painting, that's another factory that we have where, you know, it is just one element, but we can do modular M&E installations, and you can do, as we've heard, get that quality control off-site, which then reduces the amount of reworking, you know, reduces potential issues with quality on-site and gets things done quicker to, you know, a more guaranteed standard. So that's all I've got on my slides, and I think just for me, you know, the biggest takeaway and what I'm focused on is like, how can we scale up these circular practices? You know, we're already great in terms of construction about reusing excavated materials, making sure that they're reused in landscape, in foundations. We're also very good at reusing claimed stone aggregates and also recycling of steel and concrete. But there's these other, you know, elements. How do we do that on scale and in a more consistent manner, basically? And that's it from me, Mike.
Okay, thanks, Paul. That's great. If you just unshare your screen. Thanks so much for our speakers. That's food for thought, as they say. Now we've got some time for questions. I don't know if anybody would like to ask a question. I know that was a lot of information covered. Is there anybody that would like to ask our panel of speakers some questions? I might actually just ask one question to kick off if we can, and then let everybody digest all the information that you've asked. I suppose to the whole panel, how can you influence customers and clients to embed circularity so they don't just assume that embedded circularity will be an additional cost to their project? And that's to the whole panel. Maybe we should just go one by one. So I'll go over to you, Nick, first, maybe.
I was going to defer to all the amazing examples from likes of the speakers we had. I mean, I think, as I can't remember the phrase, like necessity breeds innovation, but it seems that it's you know, something like that. It's really true that from particularly Lily's examples there, but also some parts of Paul's, that you know, the real driver for circularity will be the fact that it's the best option. And I think that sometimes when we talk about circularity, we almost, and sort of, I say circularity, like circular economy principles in construction, we maybe build up a bit of or there's a perception, a bit of mysticism around it, that it's this, you know, crazy thing that is achievable in the future, but actually it's application of logic to problems, and maybe in ways which we need advocates like Paul, Lily, and Aythan to promote, and you know, they are already, but we need more widely people who have the ear of the client to be able to explain these solutions. And you know, I think that's one way we'll get a definite foot in the door. It's not, you know, the big problem is the widespread adoption of it, and as one of them, it might be Nathan said, you know, we do need a bit of policy to back up the implementation, but we can't rely on that. We need things to be happening. So it's really, really good to see that things are happening. You know, the things Paul highlighted are really high profile projects, which are good. I think as well, we need to stop maybe explaining exactly how technically things are done, and we need to show that they're just possible. So all the presentations did that, because I think if we can demonstrate to clients that you know, circularity is possible and it's the best option, then it's not so important. They'll figure out how. They'll get in experts, or they'll gen up on it themselves. You know, it's I don't see that as being the major obstacle. I think just the demonstration and you know, creating the spark in people's minds. That's my sort of thoughts on it.
Okay. Thanks, Nick. That was interesting. I saw Aythan was nodding, but I'll go over to you now just to put your comments into my general question.
Just a very quick answer for me is sadly money, and you need to. And I think I tried to give a couple of examples in what I was saying there about when you align sort of economic outcomes with circular practice. Because everyone sees these things, everyone sees the sustainability agenda and greenwash. I mean, we tried to put in recycled worktops in some kitchen refurbs recently, and because they're green, they're significantly more expensive than a standard laminate worktop, and yet it's coming from materials which have arisen from somewhere else. So why is it more expensive? Because it attracts that green tag. All the time that green sustainable practice, however you want to label it, is punitively expensive. People aren't going to do it. So if you can point out to people, or you can find mechanisms by which they can see that it's lower cost in the long run. I mean, using the technical term, it's sort of giving a financial cost to externalities. Making people see this. And we find the best clients for thinking holistically and sustainably are those who have to hold on to their estate for significant amounts of time. We work with a lot of landed gentry who you think wouldn't care about this stuff at all, but they're the most sustainable people you will come across, because as far as they're concerned, they want the next 5 generations of their family to be living in the same place the last 5 generations lived. So they really care that this stuff will last and will be low cost impact for significant amounts of time. The worst people are those with a 5-year planning horizon, asset managers who just want to flip and flip and flip. They're the ones you'll never convince. If you can align people financially with these objectives, they'll agree. And we need to keep that in mind.
Yeah, no, I totally agree with that. You've got to realize that what you balance, and it's for the generations of the future. And what about you, Lily? What's your thoughts on my general question? You're on mute.
Estate side of things.
Sorry, say that again, Lily.
I can't agree with you more about the estate side of things. I think definitely they are the people who want to build for hundreds of years, and we see that as well. On a more sort of micro level, I think if we can get to a point where we're repeating, there is an economy in repeating. So the project I spoke about, our first version of that was more expensive, but as we were able to roll that technology out across multiple sites, there was an economy in doing so, and the client could see that we were demonstrating that it was actually cheaper overall, whilst also being more sustainable. And I think that was really important. But across the industry, that is possible. It's just a task that needs everybody to get on board with.
Yeah, I agree. I think what I know that I'm speaking to a lot of different people, it's from the beginning, it's all the way along from the architect, the surveyor, the project manager, all the way to the construction company. You have to get everybody involved in that process. And then you can also see the client actually long term and won't necessarily be that much more expensive, maybe in the short term, but not necessarily in the long term. What about you, Paul? What are your thoughts?
Yeah, I think it's only going to become something that is more consistently addressed, and that's driven by the fact that particularly in Scotland, the climate emergency and the goal of net zero, there's no way that we can achieve that without actually thinking through circular economy and rethinking the way that we actually do some things at the moment, and finding new ways of doing stuff. Also, the biodiversity emergency, I think it's something we've talked a lot about, the sort of hard element of the built environment, but how is landscaping and the practice of making sure that we manage our soils and the quality of them fitting into these developments. So for me, they're the two drivers, and I just think that it, with the fact that Scotland has set the net zero challenge, we've got the big planning review coming up, and there's a lot that's going to drive the adoption of circular economy thinking, and I think it's going to be, for me, I'm seeing it more where customers are going, right, how am I going to get to net zero? And net zero is about embodied carbon, also carbon in use, having a conversation around, right, instead of demolition, what about refurbishment? Well, you can't do that unless you actually have a digital model of what you've already got. So, it's about that investment up front in having digital models of our built also natural environment and using that to drive our decisions. And out of that will come opportunities to grow things that we're already good at, such as lower grade, but low grade concrete is already used. Steel is recycled quite a lot, but how can we recycle steel? How can we make sure that that's a consistent specification, because then that recycled steel means that it'll come from UK steel mills. So instead of new fabrication. So it is happening, and they're all drivers that are going to push us along more. But I really do see that as Nick said, we do need policy, and I think the practices are already in place. If we had a planning system that drove this thinking, if we had a CDM construction design management legislation that put the ownership onto people who own assets, then that's already there. I think we could just get cracking on with it, but we do need that investment in digitisation, because for me, digitisation 10 years ago was right, let's get rid of all of the paper, and now we're left with a blank sheet. We do need to have digital models so we can apply the technology and our thinking to it. And I'm seeing it more and more. I sit on Zoom calls through this lockdown, and we're using also BIM and different tools to talk about building design. Is it the most efficient at the floor plates? Right, well, let's reduce the floor plates, change orientation, and that reduces the amount of virgin material that you need to use. So you've already got a saving there. So that is where we're heading. It's just how quickly we can get there for me.
Yeah, no, I totally agree, especially since we've had the lockdown. I think people realise the power of digital and digitisation. So you're completely right. And we're nearly out of time. Is there anybody who wants to do a burning question before we finish? I haven't seen a couple of comments in the chat box, but nothing just now. I think we've covered everything. I think first of all, I'd like to thank our panel of speakers today, to Nick, to Lily, to Aythan, and to Paul for your thought-provoking, interesting presentations and some great case studies to really bring circularity to life. Myself and Lauren will follow up with a copy of the presentations and a link obviously to this webinar for people who have missed it. And there's any additional support that Circular Edinburgh and Zero Waste Scotland can help you on your circularity journey. And I hope you all have a wonderful day. Take care and see you again soon.